Earth. We've reached our home planet, the densest in the solar system. At the Earth's crust is a relatively thin layer that takes up only 1% of the Earth's volume. Along with the upper part of the mantle, it's broken into tectonic plates. They move as fast as your fingernails grow and let heat escape from the Earth's interior. The crust is mostly made up of oxygen, silicon, aluminum, iron, and other minerals. The mantle surrounds the outer core. This layer is about 1,800 miles thick and makes nearly 84% of the entire Earth's volume. It consists of silicate rocks rich in iron and magnesium.
The threat has passed.
At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of two parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees. That's as hot as the surface of the sun. And the pressure there is 3.33 million times the atmospheric pressure at sea level. Time we leave our planet behind and move to the red planet. It's the last of the inner planets, which are also called terrestrial, since they're made up of rock and minerals. Mars has a core made mostly of iron, nickel, and sulfur. It's between 900 and 1,200 miles across. The core doesn't move. That's why Mars lacks a planet-wide magnetic field. The weak magnetic field it has is just 0.01% of the Earth's. The mantle surrounding the core is composed of thick silicates, oxygen, and some other minerals. You can probably compare it with soft, rocky toothpaste. Yeah, brush your teeth with that. The Mars mantle is also much thinner than the Earth's. It's just 800 to 1,100 miles thick. The planet's thin crust consists of volcanic basalt rock. Astronomers believe it isn't broken into tectonic plates and remains in one piece. The crust is covered with fine reddish dust that looks like talcum powder. The next planet on our way is the largest planet in our solar system. Jupiter is a gas giant. If the planet was 80 times as massive as it is now, it would have a chance to turn into a tiny red dwarf star. It's still unclear whether the planet's core is a molten ball of liquid or a solid rock 14 to 18 times the mass of Earth. There's even some evidence the gas giant's core might be melting right at this moment. The temperatures at the center of Jupiter reach 63,000 degrees. Around 90% of the planet's atmosphere is hydrogen. The remaining 10% is made up of helium with tiny traces of other gases. Under immense atmospheric pressure, hydrogen and helium gases turn into a dense fluid the deeper you go. Closer to the core, this liquid becomes the mixture of metallic hydrogen and helium. There's no solid ground on the planet. That's why astronomers define the planet's surface as the point where the atmospheric pressure equals that on Earth. You wouldn't be able to stand on that surface though. It's just another layer of gases. But the gravitational pull there is more than 2.5 times more powerful than that on our planet.